Chapter 3.1, Investigating Quadratic Functions in Vertex form. A quadratic function can also be written in vertex form, which is y equals a bracket x minus p close bracket squared plus q, where again a cannot equal 0. A can't equal 0 for the same reason as in general form, because then it makes the x squared term disappear, and we need the x squared term for the definition of a quadratic function. Compare y equals x squared and y equals x squared plus q. Example, graph y equals x squared plus 3, and y equals x squared minus 5. Let's use our graphing calculator. Go to y equals, clear what you had, and enter x squared. Hit graph or draw, and we get the base quadratic function. We could also make a table of values or use the table from our graph. To get to the table for TIs, do second graph, and for Casios, go menu and then graph, and then F6 for table. So we have a point at 0, 0, which makes sense. When x is 0, 0 squared is 0. We also have a point at -1, +1, so x is -1, y is +1. And when x is -2, y is +4. -2 squared is +4. And when x is -3, y is +9. Right there. Going the other direction. When x is 1, y is 1. When x is 2, y is 4. And when x is 3, y is 9. Then we can join our points together. And there is the graph for y equals x squared. Next, we want to graph y equals x squared plus 3. So go back to y equals or menu graph. And we have our x squared. I'm going to leave that one there, and I'm going to graph y2 as x squared plus 3. Push graph or draw, and we see it's the red graph. So notice it looks very similar to the blue graph, but it's up 3 units. If I go to my table to help me find some values, second function graph on a TI, or menu table on the Casio. Now I'm looking at the red numbers for my y value. So x values are still on the left, the black numbers, and y values are the y2 values. At x equals 0, I see that y is 3, so x is 0, y is 3, right here. At x equals -1, y is +4, so -1, +4. When x is -2, y is +7, -2, that's 4, 5, 6, 7. When x is -3, y is 12, that's off my graph, so I am not going to do that one. I'm going to go the other direction. When x is +1, y is 4. And when x is +2, y is 7. And then I can attach those points. And that is the graph of y equals x squared plus 3. Next one, go back to your graphing area. I'm going to leave the 2 functions that are already there, and I'm just going to graph the third function, which is x squared minus 5. And this is the black graph. So again, it looks the same as the other two. It's just been moved down 5 units. Go to my table. And I see that when x is 0, y is -5. I'm going to do this one in blue. So x is 0, y is 1, 2, 3, 4, -5 down here. When x is -1, y is -4. When x is -2, y is -1. So x is -2, y is -1. When x is -3, y is +4. -3 up to 4, right there. When x is -4, y is +11. That's off my graph, so I'm not going to worry about that. Going in the positive direction now. When x is 1, y is -4. When x is 2, y is -1. And when x is 3, y is up to 4. Join those points together. And that is the graph of y equals x squared minus 5. What does the value of q determine? Looking at our equation, q is the number being added outside the brackets. So +3 here and -5 here. Notice we don't have any brackets in these equations because the only thing in the brackets would be an x. So we don't need brackets around the x and then squared. Let's take a look at our vertex. The vertex for the first one, y equals x squared, is at 0, 0. For the second one, y equals x squared plus 3, the vertex is at 0, 3. And for the third one, y equals x squared minus 5, the vertex is at 0, -5. So do you see the connection? We have 0 for the y value of the vertex, for x squared, which would be x squared plus 0 if we wrote it with a q value. We have 3 for the y value of the vertex for the function x squared plus 3. And we have -5 for the y value of the vertex for the function x squared minus 5. Then the q value is the y value of the vertex q moves the graph or the parabola up or down. This is known as vertical translation or shift, vertical shift, which is something you'll learn a lot more about in Math 30-1. If q is greater than 0, the parabola moves up. If q is less than 0, the parabola moves down. Compare y equals x squared and y equals x minus p all squared. Example, graph y equals x squared, y equals x plus 3 all squared, and y equals x minus 5 all squared. Again, let's use our calculators to help us with this. Go back to y equals. We're going to clear or delete the 3 equations we had entered. Go back to y1. Oh, I guess I could have left the first one. That's okay. X squared, graph. We should be fairly familiar with graphing this one now. We've seen it many times. We can use our table. We've got a vertex at 0, 0. When x is -1, -1 squared is +1. X -2, -2 squared is +4. And x -3, -3 squared is +9. +1 squared is 1. X +2 squared is 4. When x is +3 squared is 9. Join the points together. And that is the graph of y equals x squared. Go back to y equals, go down to y2, enter bracket x plus 3 close bracket squared. Graph that. And we see it looks very similar to the first graph, but it's been moved to the left. I can use my table. When x is 0, y is 9. When x is 1, y is 16. That's too big, so I'll go the other direction. When x is -1, y is 4. When x is -2, y is 1. When x is -3, y is 0. When x is -4, y is 1. When x is -5, y is 4. When x is -6, y is 9. And then I can join those points together. And that's our graph of y equals bracket x plus 3 close bracket squared. Go back to y equals, down to y3, and enter bracket x minus 5 close bracket squared. Graph that. And again, it looks the same as the other two, but it's off to the right. Use our table. When x is 1, y is 16. That's too big to graph. When x is 2, y is 9. When x is 3, y is 4. When x is 4, y is 1. When x is 5, y is 0. When x is 6, y is 1. When x is 7, y is 4. And when x is 8, y is 9. Attach those points. And that's the graph of y equals bracket x minus 5 close bracket squared. What does the value of p determine? Let's take a look at the vertex of each parabola again. The original one is 0, 0. The second one is x is -3, y is 0. And the third one is x is 5, y is 0. Do you notice the connection between the vertex and the equation of the function? Y equals x squared has a vertex at 0, 0. If we were to write y equals x squared with a p-value, it would be bracket x minus 0 close bracket squared. The second one has an x value of -3 for the vertex, and the equation of the function is x plus 3 all squared. Notice that in vertex form, it's written x minus p. So whatever p actually is, it'll be written with the opposite sign when we put it in the function. So here p is positive, and we write x minus p. So here, where we have plus 3, that means p equals -3. So we can write y equals x plus 3 all squared is y equals x minus -3 all squared. So p is -3. And then for the third one, we have an x value of 5 for the vertex. And we see that p equals 5 in the function because we have x minus 5, so that means p equals +5. So p is the x value of the vertex. He moves the parabola left or right. This is called horizontal translation. Or shift, which again you'll learn a lot about in Math 30-1. When p is greater than 0, the parabola moves right. And when p is less than 0, the parabola moves left. So now we see why it's called vertex form. We have y equals a times x minus p squared plus q. And we can now say that the vertex is pq. So when a function is written in vertex form, you can read the vertex from the function. Compare y equals x squared and y equals a times x squared. Example, graph y equals x squared, y equals 4x squared, and y equals 1/4x squared. Again, we'll use our calculators. Go back to y equals, clear whatever you had there. Actually, we'll leave y1 because it's going to be the same. Clear the other two. So graph y1. We can use our table again, but we should be pretty good at this one. We have a vertex at 0, 0. At x equals -1, y is 1. X is -2, y is 4. X is -3, y is 9. And x is +1, y is 1. X is +2, y is 4. X is +3, y is 9. Join those points together. That's our graph of y equals x squared. Go back to y equals, down to y2, and enter 4x squared. No brackets here. We don't want the 4 to be squared. We want 4 and then times x squared. Graph that, and we see that we have a more narrow looking parabola. can use our table. I still have a vertex at 0, 0. At -1, y is 4. And at -2, y is 16. That's too big. At +1, y is also 4. I can join these points together. And that's our graph of y equals 4x squared. Go back to y equals, down to y3, and enter 1 over 4x squared. If you can't enter fractions, then you just do bracket 1 divide 4 bracket and then x squared. If you can enter fractions, then enter 1 over 4 as a fraction. Just make sure you then move to the right so you're out of the fraction before you put x squared, because you do not want the x squared to end up on the bottom of your fraction. Graph that, and we get this much wider parabola. Use our table to plot some points. And we still have a vertex at 0, 0. At -1, we have a y value of 0.25. So I'm going to just go to whole numbers. At -2 for the x, we have a y value of 1. At -4 for the x, we have a y value of +4. At -6 for the x, we have y equals 9. And then we'll go the positive direction. At 2, x equals 2, we have y equals 1. At x equals 4, we have y equals 4. And at x equals 6, we have y equals 9. Join those points together. That is the graph of y equals 1 over 4x squared. What does the value of a determine? A determines how wide or narrow the parabola is. We saw that for y equals 4x, where a is equal to 4, the parabola gets more narrow. So for absolute value of a being greater than 1, makes the parabola narrower. And then for 1 over 4x squared, where a is 1 over 4, which is between 0 and 1, if the absolute value of a is between 0 and 1, that makes the parabola wider. Next, we're going to look at what happens when a is negative, which is why I wrote absolute value of a instead of just when a is greater than 1. Compare y equals x squared and y equals negative x squared. Example, graph y equals x squared and y equals negative x squared. Go back to our y equals. We already have y equals x squared. Just clear y2 and y3. Graph y equals x squared. Again, we should be pretty good at this one by now. We have a vertex at 0, 0. When x is -1, y is 1. When x is -2, y is 4. When x is -3, y is 9. And it's symmetrical on the other side of the y-axis. So when x is 1, y is 1. When x is 2, y is 4. When x is 3, y is 9. Join those points together. And that's our graph of y equals x squared. Go back to y equals. In y2, enter negative x squared. Graph that. And we see that it looks the same, it's just going the opposite direction. We've already discussed how when the a value is negative, the parabola opens down. When the a value is positive, the parabola opens up. So we're just reestablishing that concept. We have the same parabola, but it is opening down. I can go to my table to plot the points. Still have a vertex at 0, 0. Now when x is -1, y is -1. When x is -2, y is -4. And when x is -3, y is -9. Going the other direction, when x is +1, y is -1. When x is +2, y is -4. And when x is +3, y is -9. Join those points together. And that's our graph of y equals -x squared. What does the sign in front of a determine? As we've already talked about, the sign in front of a determines the direction of opening for the parabola. The transformation term for this is reflection across the x-axis, which again is a big part of Math 30-1. But for Math 20-1, what we really just want to know is that when a is less than 0, the parabola opens down, which then means it has a maximum. And when a is greater than 0, the parabola opens up, so has a minimum. Example graph y equals bracket x minus 5 close bracket squared minus 4, and find the following: direction of opening, vertex, max min, equation of the axis of symmetry, domain, range, and intercepts. The function's in vertex form. That means we can read the vertex from the function. Vertex form is y equals a bracket x minus p close bracket squared plus q, and the vertex is the point p, q. Remember that p is opposite of the sign that is with it in the function. So here p is negative, but it's actually positive. Then here we have x minus 5, which means p is actually positive 5. So our vertex is then 5, and the q value is exactly what it is, so plus q, positive q. Since this is negative 4, our q is negative 4. So our vertex is 5, negative 4. We got that information without needing to graph. Direction of opening, we can also get that without needing to graph. The a value is in front of the brackets. Because there is no number there, it means it's positive 1. So direction of opening would be up, because a equals 1, which is greater than 0. Going back to part B, determining the max or min. We can do that now because we know that a is positive. So the parabola opens up. If the parabola opens up, the vertex has to be at the bottom. So that's a minimum value. And the minimum is the y value of the vertex. So we have a min value of negative 4. We can also do the equation of the axis of symmetry. Remember, that is a vertical line, so it's written x equals, and then it's the x value of the vertex, which in vertex form is the p-value from the function, so that is 5. X equals 5 is our axis of symmetry. I can draw that on my grid here. X equals 5 is here. Just draw a dotted vertical line at x equals 5. That's our axis of symmetry. I can also do my domain without needing to graph the function. The domain of all parabolas is XER. So as long as it's not a word problem, your domain's going to be XER. X such that XER. Because the parabola continues going left and right, getting wider as it goes up in this case. We can also do our range because we know our minimum. The parabola opens up because a is positive, and the minimum value is negative 4. Then our range is all y values greater than or equal to the minimum, which in this case is negative 4. So range is y such that y is greater than or equal to negative 4, comma, y is an element of the real numbers. So all real number values that are greater than or equal to negative 4. And then the intercepts we can do both graphically and algebraically. Let's graph our function next. So I know the vertex is at 5, negative 4, 5, negative 2, negative 4. Right here is the vertex. Let's use our graphing calculator to help us out. Go to y equals, clear what we had, go back up to y1, enter bracket x minus 5, close bracket, squared, and then minus 4. Graph that, and here's what we get. We can use our table to find some values. And we have when x is 1, y is 12, that's too high. When x is 2, y is 5. X is 2, y is 2, 4, 5, right there. When x is 3, y is 0. When x is 4, y is negative 3. When x is 5, y is negative 4. We already had that. That's our vertex. When x is 6, y is negative 3. When x is 7, y is 0. When x is 8, y is 5. Join those points together. And there's our graph of y equals bracket x minus 5 close bracket squared minus 4. Our x and y intercepts, we can see from the table, the y-intercept is when x is equal to 0, so that would be at 21. And the x-intercepts are when y is equal to 0, which we're at x equals 3 and at x equals 7. We could also go back to our graph and find these values here. So second trace, to find the y-intercept, do number 1, and then put x equal to 0, enter, and it'll tell us y is 21. On the Casio, do F5 and then F4 for intercept, and it'll tell you y is 21. We're going to also do it algebraically, so for the y-intercept, remember we set x equal to 0 and then solve for y. Y equals bracket x minus 5 close bracket squared minus 4. Set x equal to 0, y equals bracket 0 minus 5 close bracket squared minus 4. And solve for y. Y equals negative 5 squared minus 4. 0 minus 5 is negative 5. Y equals negative 5 squared is positive 25. You can always use your calculator to do that. Make sure you put the brackets in the calculator though, otherwise it will give you negative 25, which is incorrect. So this is 25 minus 4. And 25 minus 4 is 21. So y equals 21 is the y-intercept, which is the same as what our calculator told us. X-intercepts we saw from the table, they were 3 and 7. We can also find them from the graph. Second trace number 2, and then we have to go left bound, right bound. So we have to do this twice, remember? I'm going to do the x-intercept that's over here first, so left of that x-intercept would be above it. Hit enter. Right of that x-intercept would be this section below. Hit enter. Probably hit enter again, and it's at x equals 3. Repeat that process, second trace, number 2, but now I'm doing this x-intercept, so left of this x-intercept would be below. Hit enter. Right of that x-intercept would be above. Hit enter again if you need to, and it's at 7. Casio users just do F5 and then I think it's F1 or F2 for root, and it'll tell you one of them. Use your right or left arrows, and it'll tell you the second one. Let's do it algebraically. We're going to set y equal to 0 and solve for x. Y equals bracket x minus 5, close bracket squared minus 4. Set y equal to 0, 0 equals x minus 5, close bracket squared minus 4. We want to start isolating for x. Add 4 to both sides. We get 4 equals bracket x minus 5, close bracket squared. Now we need to get rid of the square. We do that by square rooting, but again, we don't know if x minus 5 started as a positive or negative before it was squared. So we have to consider both options. So we do plus minus the square root of 4 equals plus minus the square root of x minus 5 squared. That simplifies to plus minus the square root of 4 is 2 equals x minus 5, because our square and square root undo each other, so we just have x minus 5. Now we add 5 to both sides, and we get plus minus 2 plus 5 equals x. there's two options. The reason I didn't just add 5 to 2 and say now I have plus minus 7 is because there's two different options. We have positive 2 or we have negative 2. So we have to consider both. If it's negative 2, then we have x equals negative 2 plus 5, which means x equals 3. Or we have positive 2, so x equals 2 plus 5, which gives us x equals 7. Example, write the equation of a quadratic function that passes through 1, negative 2, and has a vertex of 3, 2. So this says a vertex of 3, 2. Remember that in vertex form of a quadratic function, the vertex is PQ. So this is P and this is Q. Then y equals a bracket x minus p close bracket squared plus q, which is the vertex form of a quadratic function. We can replace p and q with the values that were given. P is 3, q is 2. So plug those into the function. Y equals a bracket x minus 3 close bracket squared plus 2. Now to finish the function, we need to determine the value of a. To do that, we need to be able to plug in something for x and y so that we only have one variable, and then we can solve for that variable. In the question, we were given a point, 1, negative 2. Any point that's on a function is just an x and y value. That means that we can sub in 1 for x and negative 2 for y into our function. So then we have y is negative 2 equals a bracket x is 1 minus 3 close bracket squared plus 2. Now the only variable we have is a, which means we can solve for a. So start isolating a. I'm going to subtract 2 from both sides to move this positive 2 to the left. I get negative 4 equals a times, I can simplify the brackets. 1 minus 3 is negative 2, and then squared. Negative 4 equals a. Negative 2 squared is positive 4. And then I can divide both sides by that positive 4 to move it over and get a by itself. And I get a equals negative 4 divided by positive 4 is negative 1. If you need to use your calculator for that, that's fine. Just use your calculator so you get the right answer. Now that I have a, I go back to this part where I had p and q filled in, and I just fill in the a value, and then I have my function. So the equation of this quadratic function would be y equals negative or negative 1, doesn't matter, bracket x minus 3 close bracket squared plus 2. Let's write some notes for what we did, so you can use that when you're doing practice problems. So in this step, we subbed in the vertex for P and Q. In this step, we sub in the given point for x and y. Then we solve for a. And then finally, to write our equation, we sub in the values for a, p, and q. In your equation, you should still have the variables x and y, but a, p, and q should now be numbers. So a is -1, p is +3, and q is +2. So we get y equals negative bracket x minus 3 close bracket squared plus 2. Just gonna fix this bracket, it's annoying me. That brings us to the end of Chapter 3, Lesson 2.